Solving absolute value inequalities, part 1. In this video, we'll be talking about solving inequalities that involve absolute value. So let's try to first understand the meaning of this word inequality. It's the opposite of equality. When you have an equation, you write with an equal sign, and then you say that both left and right sides are equal. Now, when it's not equal, it could be either less or more. It could also be less than or equal to. So this includes the case of equality as well, or greater than or equal to. So there are these four kinds of inequalities: less than or equal to, greater than or equal to. In this part, we will focus only on these two inequalities: less than or equal to. So your equation is going to have absolute value and one of these two inequalities. Now, when you solved absolute value equations, then you get most of the times two numbers as your solution. Now, if you're not sure how to solve absolute value equations, I have a video on that. Please watch that first. And when you solve an absolute value equation, you get maybe two numbers. So if you get two numbers, you say x equal to 5 or x equal to 7. You could write the same using braces. You write 5, 7. Now 5, 7 inside braces means on the number line, you have these two numbers, 5 and 7, as your answers. So that's what 5, 7 means. When you solve an absolute value inequality, you don't just get one or two numbers, but you get most of the times an entire interval of numbers. So when you write down, when you specify that your solution set consists of everything between 5 and 7, but not the boundaries. So I'm going to have that open. This is, you write this using parentheses 5, 7, and you say that this is open interval 5, 7. What does this mean? It means everything between 5 and 7, but not the boundaries. Now, sometimes you want to specify everything between 5 and 7, including the boundaries. So in that case, your boundary is also filled. So this is how you would graph, and your boundaries are included. And now you use brackets. So 5, 7. Now these are called braces. So these are braces. These are parentheses. And these are brackets. These are intervals. Interval means it includes values between 5 and 7, between any two numbers. And if it's open, then the boundaries are not included. If it's closed, the boundaries are included. Now, when you solve an absolute value inequality, usually you get either this or that as the answer. It's not going to be just two numbers. So this is what I want to tell before I work out some examples. Now let's think about solving an absolute value inequality. So say I have this inequality. Absolute value of x is less than 10. So how would I solve this absolute value? Well, the idea is on the number line, I have a 0 somewhere. And what absolute value? Absolute value of x means the distance of x from 0. So you could read this as the distance of x from 0 is less than 10, which means you can't go any more than 10 units on either side of 0. So if you go this way, you're going to have positive 10. And if you go on the left side, these are the two ways in which you could move. This is also 10 units. Then this number is negative 10. And what I'm trying to look for is all those numbers whose distance is within 10 units of 0, which means it includes everything between these two numbers, negative 10 and positive 10. And notice, I have the first kind of inequality, less than, not this less than or equal to. So if I don't have the equality in my inequality, then the boundaries are not included. So the boundaries are going to be open and it's going to include everything between negative 10 and positive 10. So how do you write this? You say x, you can use open interval negative 10 to positive 10. You can write it this way. Or you can say that x is between negative 10 and positive 10, right? This is between negative 10 and positive 10. So you can put x between those two values. So you want to write negative 10 first, less than x less than 10. I like to say that x is sandwiched between the negative 10 and the positive 10. So that's how you would solve. So that's example 1. Absolute value of x is less than 10. Now, you may not always have x for the variable. Sometimes you use a different letter. So if I'm going to say absolute value of m is less than 4, then what's my answer? Well, just like in the previous example, I'm going to sandwich m between negative 4 and positive 4. I can say that. So this is one way to write. Another way to write is using interval. So x or m is between negative 4 and positive 4. And I could also graph by specifying negative 4, positive 4 on the number line. But since it's open interval, the boundaries are going to be open. We are not going to include them. And this is the solution. All right, so whether you use x or m, it does not matter. If it is less than, then you're going to have an open interval. Now, what would you have if it is something like y is less than or equal to 2? Well, this time, I'm going to again sandwich y between negative 2 and positive 2. So I'm going to have negative 2, but this time I'm going to have negative 2 less than or equal to y less than or equal to positive 2. If it is less than or equal to, I'm going to have less than or equal to in my solution. And since I'm including negative 2 and positive 2, this is going to be a closed interval. So I'm going to use brackets, negative 2, positive 2. And how would I graph that? This time it's negative 2, to positive 2, but I'm going to include the boundaries. All right. So we looked at 3 examples where the left side was quite simple. All I had was absolute value of the variable. Now, if I don't have something like that, but let's say I have absolute of, let's use k this time, plus 2 is less than 9. Now, before I write down the solution for k, I need to get rid of the plus 2. So that's the difference between this problem and the earlier problems. In all the previous problems, you just had absolute value of the variable. But if you have something else, then you got to subtract 2 from both sides. You got to get rid of that. Maybe draw a line again. And now you have absolute value of k less than 7. So at this point, we can put k between negative 7 and positive 7. So there you go. That's using inequalities. You can also express this using interval. And you can graph negative 7 to positive 7. And since the boundaries are not included, the boundaries are going to be open circles. All right, so sometimes, let's look at one other example. This time, let's say absolute value, 3 times absolute value of, let's use t this time. I'm using different letters to specify that it does not matter what letter we are using, is less than or equal to 12. Now this time we have this 3 in front of the absolute value. We need to have just the absolute value, which means we need to get rid of this 3. And since this 3 is multiplying the absolute value of t, I'm going to divide both sides by 3. So when I divide both sides by 3, I get absolute of t on the left, and then 12 divided by 3 is 4. So I have that. Now absolute of t is by itself. So we are ready to write down our solution. Put t between negative 4 and positive 4. And be sure to use the same inequality that you are seeing in your original problem. If it is less than or equal to, you got to have less than or equal to here. So that's using inequalities. I also like to show you how to write using interval notation. Since we are including the boundaries, this is going to be a closed interval. So we are using the brackets. And finally, I want to show you the graph. It's between negative 4 and positive 4. And since the boundaries are included, your boundaries are going to be solid circles. So that's what you have. Now let's look at example 6, where we may have to do some more work than we did in examples 4 and 5. So say I have 2 times the absolute value of m plus 3 is less than or equal to 7. So this time I have a whole lot more on the left side than just the absolute value of m. There are actually 2 terms. One term is 2 times absolute value of m. This is one term. And then there is plus 3. Now I need to get rid of the other term first. So I will get rid of the plus 3 by subtracting 3 from both sides. So let's do it. Then the plus 3 minus 3 cancel each other out. I'm left with 2 times the absolute value of m. Plus 3 minus 3 are gone. Is less than or equal to 7 minus 3 is 4. Okay, so this looks a little bit better than what I had before, but I still need to get rid of the 2 in front of absolute value of m. And since it's multiplying, I'm going to divide. So let me copy the equation. So that's 4. It's positive 4. I'll divide both sides by 2. And then 2's cancel each other out. I have absolute value of m less than or equal to 4 divided by 2 is 2. So now that I have just the absolute value of m, I'm ready to write down the solution. The solution is put m between negative 2 and positive 2. So negative 2 less than or equal to m less than or equal to 2. Or using interval notation, I'll be using closed interval negative 2 to 2 because the boundaries are included. And the graph will also show that we are including the boundaries negative 2, positive 2. So that's the graph. And let's look at one more example where I have within the absolute value. Now, it's not going to be just one variable. Let's say I got 3m plus 5 is less than 20. Now this time, what I have on the left side is just the absolute value, but it's not just the variable. It has something more than the variable. But the idea is still the same. When you have absolute value by itself on one side of the inequality, you can put this quantity 3m plus 5, you can sandwich this between the negative and positive of 20. So I'm going to write negative 20 on the left, positive 20 on the right. Now the question is, we did not solve for m. We still have to solve for m. Notice it's 3m plus 5. So we need to get rid of the plus 5 first. So this time we will subtract 5 from everywhere. So I'm going to subtract 5 here, minus 5, minus 5, minus 5. And then what do we notice? So this time there are 3 sections, so I'm going to draw 2 lines. Negative 20 minus 5 is negative 25. And then copy the less than sign. 3m plus 5 minus 5. The plus 5 minus 5 cancel each other out. So it's 3m less than 20 minus 5 is 15. Now we have 3m. How do you get rid of the 3? You divide everywhere by 3. So that's what we will be doing next. So let me copy that. Negative 25 less than 3m less than 15. And I'm going to divide everywhere by 3. So notice I'm dividing by positive number. So inequalities remain the same. They don't flip. And then negative 25 divided by 3. 3 does not go into 25, so I can't simplify that. So I'm going to leave it at negative 25 over 3. Here 3 and 3 cancel each other out. M and this is less than 15 divided by 3 is 5. So there is my answer. What's the answer? The answer is negative 25 over 3 is less than m less than 5. If you want to write using interval, then it would be parentheses negative 25 over 3 comma 5. And how would you show it on a graph? Well, I'm just going to write down negative 25 over 3 and 5. I know negative numbers come on the left side, so I know negative 25 over 3 is on the left, 5 is on the right, and I got to pick everything between these two except the boundaries. So the boundaries are going to be open circle, and that's your answer. So these examples should give you some idea as to how to solve. And I have some practice problems for this video. And just like always, I'm going to write down the solution answers, not solution steps, just the answers for all these practice problems in the video description. So notice the problems start real easy. This one, number 1, you can simply write down the solution because you just have absolute value of x. In problem 2, you got to get rid of this 2 in front of x. Remember, it's 2 times. And here in problem 3, again, you got to get rid of the 2, but this is plus 2. So notice what you need to do. You got to subtract 2, right? Now, number 4, you have absolute value, but it's not just absolute value of the variable. You have x minus 1. So you'll sandwich this quantity between negative 5 and positive 5 and then add 1 on every side to solve for that. Here, this is, you have a number before the absolute value. So you first want to get rid of that. You divide both sides by 2. And this is like the last example we did where it's absolute value. So you sandwich this between the negative 9 and positive 9. And here you will get rid of the plus 5 first, and then it looks like problem 4. Here you get rid of the minus 3 by adding 3, and then it looks like problem 6. So this is all I have for this video. In part 2, we are going to talk about the other 2 inequalities. And then I'll have part 3 of the video where I will include I will include all 4 inequalities. Notice I have not divided anywhere by negative numbers. If I divide by negative numbers, then the inequality flips. And then whatever you learned in this video for less than inequality won't apply. So that's why I have chosen the problems carefully to make sure that I'm not asking you to divide both sides by negative numbers. So good luck on that, and I'll see you in the next video. Thank you.